Hi everyone. The purpose of this video is to cover finding the confidence interval for a proportion, which is section 9.1 in our book. Now in this example, we're going to use sample data to estimate a true population proportion, which is really unknown. The only way to make a guess is to use sample data and to create a point estimate, which is the 72% that we see there, and then to create a margin of error, which is what we're going to create. So to get started, we first note that we had a sample of 1,145 shark attack victims. So our N is equal to 1145. And there were 72% of those survived the attack. So our P with a hat is equal to 0.72. Now it turns out I did not actually write this, but the X value, the number that actually survived, was equal to 825. And so P hat is equal to 825 divided by 1145. And that's where the 72% came from. Okay, so now our goal is to find the 95% confidence interval for this population proportion that survived the shark attack. Now the very first thing we have to do, if we're going to do this, is we need to make sure that we have a normal distribution. If it's not normal, we're not supposed to be making confidence intervals. So right down here, we're going to check to see, is it normal? So is it normal? I don't know. Let's see. We check NP hat times 1 minus P hat to see if that's bigger than 10. So we would check 1,145 times P hat, which is 0.72, again written as a decimal, not as a percent, times 1 minus 0.72, and we're checking to see, is that in fact greater than or equal to 10? And so if you multiply all this out, it turns out to be about 230.8, which is definitely bigger than 10, so that tells us, yes, it is normal. When I say it's normal, I mean the P hat distribution is normal. So that means we are okay to make a confidence interval. In order to make a confidence interval, we need to take our P hat and add and subtract the error from it. And the error formula is right here. And the error formula requires this Z alpha over 2 thing, which comes from the normal distribution. And then we also have to know P hat and N, as you can see in the formula. Okay, so in this problem, it says we want to find the 95% confidence interval. So we want to have a 95% confidence interval. And we can find that right over here. To be 95% confident, the Z alpha over 2 we're going to use is 1.96. So Z alpha over 2 equals 1.96. And then the error is equal to that number, 1.96, times the square root of P hat, which was 0.72, times 1 minus 0.72, divided by the sample size, which is 1145. It's important to notice that the square root is of all this stuff that's on the inside. So order of operations would tell us to do the multiplication, then do the square root, and then last multiply by 1.96. So I'm going to make that clear by writing out all the steps. If you multiply the 0.72 times 1 minus 0.72 over 1145, that turns out to be 0.00017607. And then if you take the square root of that, so notice the 1.96 is going last, we'd have 0.01327, and then last, multiply by 1.96, and we get a margin of error of 0.026, or you could say about 2.6%. Okay, so now we're going to go back up here, and we're going to do the lower bound is P hat minus the error, and the upper bound is P hat plus the error. Okay, so that's what we're doing next. So the lower bound is P hat minus the error, which is 0.72 minus 0.026 which is 0.694. And the upper bound is equal to p hat plus the margin of error, which is 0.72 plus 0.026, which is 0.746. So we now have the crucial information, but we have to summarize what we found. So the summary is right here. Summary. We have 95% confidence that the true proportion of shark attack victim survivals, shark attack victim survivals is between, this is the important part here, well, there's two parts important, how confident we are and what's the interval. And we say it's between 69.4% and 74.6%. So what that means is, if you're ever attacked by a shark, there's between a 69 and 74% chance that you're going to survive, which I guess is better than no chance. All right, let me know if this has been helpful. Thanks. Bye.